So we are here for the final setup of the University of Pisa trial in the framework of the WatchEDGE project. And we are in the park of San Rossore in the middle of nowhere, and we are here to demonstrate the feasibility of the recognition of wildlife situation in the territory. And this is something that we have done deploying a distributed artificial intelligence platform that is composed by smart cameras, totally autonomous, a gateway that has some processing capability and again is totally autonomous, and edge computing that is powered by the electrical grid. The communication among this island and the rest of the world happens thanks to several networks that are wireless networks, and particularly satellite communication provided by Starlink and a Wi-Fi connection provided by Regione Toscana. You know that here we have the possibility to show the integration of computing and communication. Storage, computing, communication is becoming a unique platform thanks to the transformation of telecommunication that we want to demonstrate here. It is interesting to have a specific goal that in our case is to work during night and during day for the acquisition of images and short videos of the animal here in the park. This is a typical example of the transformation of some specific domains thanks to the adoption of ICT, information and communication technologies. In the past, there were several volunteers that were here with binoculars to try to collect the presence of the animals, counting them a couple of times during the year. And later on, there were some trail cameras that were used in fixed position to collect some of the images during night and during day. You can imagine the difficulties in collecting the SD cards, changing the batteries to obtain this type of information. On the contrary, thanks to the WatchEDGE deployment, we had the possibility to have smart cameras. We call smart since they are able to have acceleration of artificial intelligence embedded in the device. And of course, we had to use very special wireless communication to reduce the power consumption, even in a hostile environment such as the wood of the park of San Rossore. Here we use Halo, that is a version of the 802.11 that we know Wi-Fi, but there is a special standard that is called AH, where you are working under 1 megahertz of frequency and where you can collect the data thanks to this low power communication. So we call them smart cameras since they have embedded artificial intelligence. You know that artificial intelligence has three main ingredients that are data, architecture for the neural networks, and hardware accelerator. But of course, there is no artificial intelligence without communication, and in an hostile environment such as the one that we have here, everything is more challenging. And for that reason, we use Halo, that is 802.11ah, a very special Wi-Fi standard where it is possible to have symmetrical communication within the wood of the park of San Rossore. The cameras are connected with these low-power wireless communication networks. Then there is a point-to-point communication links running under 6 gigahertz, where we have the possibility to collect the information from the camera and bring it to the edge of this island. And from the island, we go to the rest of the internet thanks to the Starlink satellite communication. So there are here three types of wireless communication that are running simultaneously to get all the information and put them in two types of databases that are within our edge computer. There you collect the images, and also we collect the data from the very detailed analysis of everything that we measure: temperature, humidity, temperature in the box, working of the GPU, CPU, as will be shown by Professor David Adami in his part. So I think that is a demonstration of a cloud continuum that for us goes from the extreme edge of the network to the far edge, to the edge, and even with the collaboration of the data center, the green data center of the University of Pisa, that is even located in the same park of San Rossore. So we have this opportunity to deploy artificial intelligence with the cooperation among the different components that are also synchronized thanks to the use of GPS, and also the timing is extremely relevant in this deployment to have some inference from the data and from the multiple sensing, the collaborative sensing that we have in our deployment. So all the information collected are very relevant data set that can be used together with the data set of the images to, of course, verify that we are able to classify automatically, thanks to the artificial intelligence in a supervised learning approach, the images, but also to have the possibility to orchestrate the function of the networks thanks to the fact that we have a status, a very detailed status about throughput, delays, and even the temperature or humidity that is collected around to be able to allocate resources in a proper dynamical way.
A Grafana-based interface that has been designed and implemented for the WatchEDGE project, and it allows users to monitor the devices that are part of a test bed. First of all, it provides information about the last detected animals, and here there is the image, and there are also information about the power consumption and power produced by the different panels. Each device is characterized by its main performance parameters and also about data that are related to the temperature. As you can see here, there are a lot of information that allows the user to have a complete knowledge about the status of the system. Last but not least, there are also data about the traffic exchanged by the device, and in particular about each connected device that has been deployed in the San Rossore park. So at the end, we can say that this is a very intuitive and user-friendly interface that allows a complete monitoring of the devices that are connected to the test bed. And this is very important because system administrator may have full updated continuous knowledge about the status of a system.